In this video, we will talk about polymorphic behavior and downcasting in C++ object-oriented programming. In C++ or in polymorphism in general, we know that a derived class can be treated as if it was an object of its base class, and this is polymorphism. It is where a derived class object can take on many forms. Here in front of you, you have this code, which I have a class called shape. It has this virtual function called draw, and we have this square object, or class, which inherits from the class called shape. It has a constructor that initializes this data member, as well as some couple of functions. We have the draw function, which it's overriding it because it inherits it from the base class. And we have this getter function, which simply returns the sides of this square. Okay? Now, what I want to do here is I want to show you something very simple. We know that if I have, for example, a shape object like this. So what I'm doing here is I'm instantiating a shape object. What I could do is I could simply say shape and create a pointer that points to this object. This is very normal. Nothing is special right here. This is not polymorphism, right? So we could use this pointer to access the functionalities or members of the shape class. As you can see, I could access the draw function from the shape class. And if I try to run my code, I should get something like this, draw a shape. Okay, so nothing special right here, just creating a shape object or a base class object, and then you're creating a base class pointer that points to this base class object. Okay, now let me go down here and create a derived class pointer that points to a pointer pointing like this to a derived class object. So derived class object like this. Okay, so we could do the same thing for a derived class, which will be, in our case, the square class. So what I will do here is I'll say square like this, and pass it a parameter, which will be 4. This will be passed to the constructor. And now I could go ahead and create a square pointer. So I'll say square pointer like this, ptr. And I will assign to it the address of my square object. This is very simple also. What we just did, we created a square object, and we then created a square pointer which points to a square object. Well, basically this is a derived class pointer that points to a derived class object. Now I could use this pointer, square ptr, to access the functionalities or members of the square object. I could access the draw function, which will simply print for me the following message. As you can see, draw square of sides 4. So basically this is the overridden draw function, which is inside the class called square. What happens here is that the square class inherits a virtual function which is called draw. And when it is a virtual function, that means the function is, or the derived class is able to override this function. As you can see right here, we are overriding the draw function. Okay, so this is derived class pointer pointing to derived class object. Nothing new here. But what if I told you we could have a base class pointer that points to a derived class object? Could we do that? Well, let's see. If I had a shape pointer, or I already have a shape pointer, which is called ptr, I'm going to say ptr right here. And what I'm going to do is that instead of assigning the address of a shape object, what I'm going to do is I'm going to assign the address of a square object. As you can see, no errors. That means it's working. What if I go ahead and say ptr arrow, and as you can see, I could access a draw function. Then let's go ahead and see what will happen before explaining. As you can see, there it is. Let's ignore those 2 lines. This is the code that was, or the message that was printed because of this line. So what is exactly happening right here? Well, what we're doing right now is called dynamic binding or late binding. Now, what is dynamic binding? Basically, what we just did right now is we created a base class pointer that points to a base class object. So what we're doing exactly is that we're treating a derived class object as if it was, or as if it is, a object of its base class. And exactly what's going on here is that the compiler doesn't know yet what is the type of object the base class pointer is pointing at. When it will know is that it will know at runtime, because dynamic binding or late binding is resolved during runtime. Now, when we launch this code, you can see that the implementation of the square object was launched, not the base class pointer, or excuse me, not the base class implementation. That's because the shape, or excuse me, this shape pointer is pointing to a base class object. But does this mean that the pointer is able to access the square object attributes or data members? Let's see. If I say ptr arrow, you can see it only can access a draw function, which belongs to a shape class object, or excuse me, a shape class. Now, why is that exactly? Well, basically, this is a virtual function. The draw function is a virtual function that belongs to the class called shape. What's happening is that when you create a function as virtual, it is resolved during runtime. And again, a virtual function is actually polymorphic behavior. So basically what you did inside the square class is that you overrided this function. And so what will happen here is that because the pointer, the shape class pointer, is pointing to a derived class object, what it will do is that it can only access the virtual functions that are inside the derived class right here. It cannot access other non-virtual functions like the getSides, for example. It is a non-virtual function. So it can only access virtual functions, and that is why we were only able to access the draw function even if the pointer is pointing to a base class, or excuse me, a derived class object. Now you might be asking, what if this pointer, or what if you want this pointer to actually have access to the data members of a square object? Now what you should do? Well, basically what you should do here is you need to downcast. And what is downcasting? Well, basically downcasting is the process of casting a base pointer to a derived pointer. Let us see how. So I'm going to write right here, downcasting like this. Okay? So what I'm going to do is that I want to cast or downcast a pointer that is of type base class to a type that's called derived class. So basically why it is called downcast? Because in inheritance we have a hierarchy. So we start with the base class and then the derived class. So we're basically converting a shape class pointer to a derived class pointer, or a square pointer. So we're going down in the tree. So let's go ahead and see it. What I'm going to do is I'm going to create a square pointer. I'm going to call it downcast like this. And what I'm going to do is I'm going to use dynamic casts. And why I'm using dynamic cast? Because everything here is resolved during runtime. I'm using dynamic cast in order to cast a shape pointer to a square pointer. And what is this shape pointer? Let us use the ptr right here. So I'm going to say ptr, and what I'm doing here is that I am casting the shape class pointer to a square pointer. And now what will happen is that I will use the downcast pointer, and as you can see, I could access the draw function as well as the getSides. Let's go ahead and test it out. So I'm going to say getSides like this, and I'm going to say cout like this. And I'm going to print a simple message in order to know what's happening. So sides of square, for example, like this. And let's go ahead and see the output. So I'm going to compile and launch my code. As you can see, sides of square, which is 4. So as you can see, downcasting was successfully made. Now, usually when you are downcasting, you should always check if the downcasting was successful by saying downcast different than null pointer. Because sometimes maybe downcasting couldn't work or wasn't resolved, so you need to check out if it was resolved or not by just simply putting it inside this small if statement and checking if this pointer is null. If it's not null, then it worked. Otherwise, it didn't. Let's go ahead and see it one more time. As you can see, I'll compile and launch, and everything is working properly. Now, why do you want to use downcasting? Why do you want to cast a shape pointer to a square pointer? Well, let's see how. Let's see why exactly. So basically, what if I told you I have outside a class, I have a function called perimeter like this. And this perimeter function actually wants to take a square pointer as a parameter. So what I'm going to do here is I'm going to say square pointer. I'm going to name it ptr. What it wants to do is that it wants to simply print the area, or excuse me, the perimeter of the square. What I will say is ptr getSides like this, and I will multiply it by 4. Okay, it will simply do this. Let me put it inside a message like this. So I will say perimeter like this. And now let me remove all of this. let's say we don't have any of this, okay? What I have is I have a shape pointer called PTR, which points to a square object like this. So I'm creating now a square object. I'm using dynamic memory allocation because you can see there is the new keyword right here, okay? Now, I'm creating right now a shape pointer that points to a derived class object. We know this concept. This is called dynamic binding. Now, what I want now is that I want to find the perimeter, but I don't have a shape object, or excuse me, I don't have a square object. I have a shape pointer. So if I go ahead and say perimeter like this and pass PTR, this doesn't work because you cannot pass a shape pointer to a function that accepts a square pointer. Then what you should do here, you should use downcasting. So what you'll do is you'll say dynamic cast, and you want to cast your pointer to a square object or to a derived class object, and I'll pass my pointer right here. As you can see right now, it's working properly. And so at the end, make sure to delete the pointer because you're using dynamic memory allocation, so you need to delete the dynamically created pointer. Okay, now let's go ahead and see if this works properly. So I'm going to go ahead, compile my file, and then launch. As you can see, it works properly. So perimeter is 16. So when do you actually use this? Well, basically you use it when you have a reference to a shape pointer that points to a derived class object, and the function is required to have a square object. What you will do is to obtain your square object, you will downcast your pointer to a square pointer, and then you can work with this square pointer. Alright, this is it about polymorphism and downcasting. Alright, this is it about polymorphic behavior and downcasting. Hope you enjoyed this video. Make sure to subscribe, and I will see you in the next video.